Let's make this quick and easy effect using Houdini and Blender. So the first thing I did was to import my 3D model, which is basically a collider, and it's a perfume model. Right here I scaled it down to that scale, and now after that I added a VDB from polygon, which is basically converting a polygon geometry into VDBs. I set the voxel size to 0.005, and I set the null here as I did, and I named it col, which is collider basically. Once you were happy with the collider, now it's time to create the fluid source, which is basically a basic sphere, and which is squeezed on a specific axis here. And then once I place the sphere somewhere, then I added a flip source here, which is basically converting your polygon into an SDF, as well as it adds a bunch of particles inside it. If you go into wireframe mode, you will be able to see all those little points there, which is basically be used for simulation in flip fluid later on. I set the voxel size to 0.01 and the particle separation to be 0.0035 for the final simulation. I added a point velocity to add a bit of velocity on a specific axis, so the fluid move on that axis, which is basically -1 in my situation right now. So the points will move on that axis. So once I was happy with the fluid source, I added a null here and called it a fluid so we can use it later on. Once I was happy with the collider and the fluid source, then I added a dop network here. Inside the dop network, I have a bunch of basic nodes actually. The first thing I have here is the flip object. Well, the flip object is used to import data from the SOP level. So the first thing I did is to change the input type to particle field, and then I set the path to the fluid source outside, and then I connected the particle separation with the particle separation of the dop source node outside in the SOP network. And yeah, this is it. In the guides, I went into particles and changed the visualization to particles, which is a bit pleasing to see. Once I was happy with all the flip object settings, then I moved on into flip solver. In flip solver, first of all, for the final simulation, I set the maximum substep to 10 and the minimum to 6 and the time scale to 0.5. You can also animate the time scale if you want, but I think I wanted a uniform time scale. So once I was happy with the substeps, I went into particle motion and I turned on ID attributes, which is very handy later on when we make some bubbles. So then I moved on into volume motion. First thing I did was to decrease the box size, which is basically the domain size where fluid going to happen. We don't need a very big domain, so we just needed a small domain here. And once we were happy with that, we went into surface tension. Well, for this simulation to look good and tendrical, we were supposed to add surface tension, which basically means that there will be multiple points that will attract other points inside it. It's a lot of science, but it creates those beautiful tendricles and the transition effect. It's just very amazing to use surface tension in that effect. Once we were happy with all the settings in the flip solver, then I added a merge node to basically connect the static object. And in the merge node, I changed the effect relationship to mutual, and I added a static object. In the static object, I set the SOP path to the collider null that we created in SOP level, and then I also changed the mode to volume sample, and I also added a proxy volume, which is basically the same path that we have for the SOP path right up here to have accurate collision. Once I was happy with all the settings, I added gravity. I tested around, but I did not like gravity in that effect, so I just set everything to 0, and that's it. So once you do all those stuff, you're supposed to import all this data into SOP network. For this, I used dop.io node, which is basically adding file cache and dop import field at the same time. In the dop import field, first of all, I set the dop network. I just grabbed the dop network to here, and then I set the dop node to be the flip object, which is basically the flip object node inside the flip solver. So once I set all those values, I set the preset to flip fluids, which is basically setting up a basic field for you, which is very helpful for surfacing and stuff, to import all those attributes. Once I was happy with all the settings, I just cached it out, and after caching it out, I wanted to slow it down, so I added a retime node. If you look through the retime node, that's how it looks like. So the retime, what retime does is it's slowing the fluid a little bit to give it a little bit like a slow-mo kind of look. So in the retime node, the setting I used was to turn off the use velocity with interpolating position. It basically means if you turn this on, it's going to use the velocity of the points, so it's going to be a huge mess for you. But if you turn this off, it will help you. Not use velocity but position of the points, which is very handy actually to slow down fluids. Once I was happy with the motion of the fluid, I wanted to turn it into a mesh. For this, I use VDB from particles, where we basically set the voxel size and the point radius scale and the minimum radius scale. You can see it on the screen. You can copy those values. It's very handy in this situation. Once I turned the particles into VDB, I added a VDB reshape node to actually reshape the particles to give it a little bit of offset, a little bit of like scale. And then I added a VDB smooth node to smooth out the fluids. Then I converted all those VDBs back. Then I converted all those VDB back into polygons, and once I converted all those VDB back into polygons, I was able to create that effect. Okay, so the fluid is done basically. Now it's time to create the logo reveal effect, which is basically very easy to do. To create that effect, what you can do here is that, so once we're happy with all the fluid and meshing of the fluid, now it's time to create the reveal effect. So for the reveal effect, we're going to use our perfume bottle here. It's right here, you can see that. This is our perfume model. And then what we did here is we added a polyfill to fill any holes that is remaining because we have to. And once we were happy with this UV thing, then what we did here is that we added a boolean node. In the boolean node, I set the operation to intersect, and that's it. I just connected the fluid into the second input and my bottle into the first input. And when I set the flag into it, as you can see, it only takes the fluid that intersect with the bottle, which means it also copied the UV map from the bottle, and you can also see that it only reveals a specific part of the bottle that intersect with the fluid. And that's what we want. So if you play through, you can see it is changing, and it is very interesting. So once we created the logo reveal effect, now the basic thing here is that you apply the logo material into it, and you will see the logo when the fluid hits the bottle. Yeah, and that's our final effect. And once we were happy with that, I wanted to make some bubbles inside the fluid. So for that, I used the retime from here. You can see it here. And then I added attribute wrangle node here So in the attribute wrangle node, I just selected random points. If you look into here, I selected random points by ID and removed them. That's it. That's what I did. Like, I just chose a few points from the simulation, and now once I chose those points from the simulation, I wanted them to turn into spheres, to act as bubbles. So right here, as you can see in the copy to points node, if I look into it, I instance a sphere on top of it, and I also color it differently so I can see what's going on. So this is gonna be our bubbles, and yeah, that's it. Now you can use Houdini Karma rendering for that. You can just put in a null and import all the stuff into Solaris. But I think I'm gonna be using Blender for that purpose. So basically, what I did here is that I exported every single mesh separately. Like the first one is the bottle mask, which is that one right here, which is basically the logo mask where the logo appears. So I exported that too. And then what I did here is that I also exported the fluid separately right here, as you can see. And then I also exported the bubbles separately, as you can see it here. So once I was happy with all the stuff, let's move on into Blender and see what we can do here. So here's Blender open. Let's import all the objects. We go to File, Import, Alembic. Once you go there, what we're going to go here is that we're going to import all the Alembic file that we just exported. The first one is going to be fluid, basically. So import fluid right here, as you can see. That's our fluid simulation. Now it's time to import the Alembic file as well. The other Alembic files, which is basically the bottle mask right here. And as you can see, this is our bottle mask, which is going to be a logo, actually. And then we're going to go to File, Import, and I'm going to import the particle as well, which is basically a bunch of spheres. All right. So right here, I added some material into those objects. So let's explore our simulation objects first. Here, this is basically our logo meshes. So this is basically our mesh here that is actually showing our logo. If I go into material view, as you can see, it only shows the logo, nothing else, like so. And like the material is set to the logo right here. I added the logo material into it, and that's it. And if you look into the other one, I duplicated the same object and scaled it down. If you go into solid mode, you can see I duplicated the same object and scaled it down on X and Y axis to be glass, basically, that I'm using for my perfume bottle. And right here, if you go into material view, you can see that right here. That's how it looks like. And yeah, that's the basic effect. And if you go outside, we got the fluid as well. And if you go into render mode, you can see it's working, right?